Okie dokie. Let's get started then. So, as some people know, I've been carrying on working on Space Cats because there's a whole bunch of things that I never got around to adding during the jam because I didn't have time. And so, as I've taken to adding more stuff, I kind of thought, well, actually, I may as well just make a quote-unquote registered version with a lot more levels and other stuff, lots of other baddies. And one of the things I really wanted to get into the jam that I didn't have time for was an FMV intro, because I just think that's like one of the things that's in the tick list for shareware 90s games, was a completely irrelevant FMV intro. And I certainly didn't have time to do that. But I now have, or at least I've got the some code that will play me a video. But one of the things that I want to do is, because I'm planning to add all these other things as well, and the jam game itself only just manages to fit inside 4 meg, and even that was you had to get your auto exec back and config sys set right on a 4 meg machine to make it fit. So if I start adding more features, more images, more sprites, all of that stuff, I'm certainly going to end up using even more memory. So that's what I'm currently in the middle of doing, is trying to optimize things so that they use less memory. And where we're currently up to with that is this line here, using Crash Buffer as cache, because I've now switched things over so that rather than for the jam, every graphic and sound and all the rest, every asset was just its own file on the hard disk, and they were loaded as needed. Where now everything's packed into a single asset pack for various different reasons. But as I've just discovered the other day with testing on 86box, it turns out doing fread for a byte here and 5 bytes there and 12 bytes here is really, really slow on DOS. So yeah, going to need to do some caching, which is the idea here, which I am in the middle of. So let's get on with that. Right, where were we? If we don't have space, then give up. Make sure it's the same amount. Set the flag to say that it's open. And then all of the functions where we start reading, we need to read from the scratch instead of fread, like that. Okay. String bytes remaining. That's still going to be fine, isn't it? No, it's not, because to get the... Yeah, if we've read the entire contents into memory, then the position of the file pointer is going to be at the end of the data, so string bytes remaining is no longer going to give us a sensible answer. There's also this stuff left over for when there were some files that I was going to read from the disk, not from the asset pack. I don't think any of that is used anymore, though. I should probably check that. Because we do a scratch load, you can do a scratch load on a raw file path. There we go. That still happens. So we do that for like the options, the settings file. And we would do a write for the progress that gets saved out as well, but none of those are assets. I'm pretty convinced we don't open any assets from raw file. In fact, we can't do, because there aren't any files there to open. So yeah, if we were doing that, it would have broken. So that means we can go back to where it was, and we can say that is never going to be the case. So we can just throw it away. And similarly, there was another one. There it is. String bytes remaining. Okay, but this code is still wrong, because it's assuming that we're updating the file pointer as we go along. Right, what do I want to do then? Do I want to put the file pointer back? I don't really see how there's any point. If the whole thing's cached, why would we use any? I mean, we don't even need the file stream to be open. other than the fact that we're using it to determine if the stream's valid. Okay, we'll leave it open for now, even though we don't need it. And we will update these functions. Now I know what I was going to do. Yes, I remember. What we need to do is, in fact, I think I'd already done it. Yes, we have our own file pointer, which is what I was thinking of. Okay, fine. Let's do that then. So the skip stream is not going to use fseek. It's going to update read offset. And it should be adding bytes to it and making sure it doesn't go beyond stream.size. Stream read offset plus, well actually let's just make it's an unsigned offset equal that plus bytes normal equal to stream size. Get wrecked. Otherwise, read offsets, you will new offsets. How much have we got left? We can do that by saying, instead of group hosts, we've got one stored in the struct already, which is read offsets, and just say stream. No, we can't, because we don't want to subtract offset because it's relative. Okay, stream read offset. Yep. Read stream. That's just going to call read stream, which is up here. That is not going to do an fread anymore. That is going to. It's going to do a memcopy, isn't it? Yeah. Cold hands, memcopy 2, buffer. And I cannot remember the order of parameters in memcopy. That's quite funny. Let's ask this thing. Destination source. Yeah, I thought it was. Just checking. Destination and the source is dot. No, it's not. It's the scratch buffer. Silly me. But it's the scratch buffer plus our internal offset. Stream offset. To there from there. How much actually read? Donk. Oh, we need to return. In what way could that be said to have failed? I suppose if you read less than what's asked for. In which case it would be return. Return actually read equals bytes. Yeah. That'll do it. That's an unsigned int. It doesn't want a size. Does fread return the number of bytes read? It. Return values, and file position, return the number of objects read. Which way around is that? Okay, that's the number of objects, I think, and that's the size. So it would be the. Okay, in which case it's just actually read. Skip. Oh, I've written that one. Stream position is not doing any business with ftel. In fact, it's just returning stream read offset, isn't it? Less than 0 or too big, then set. Otherwise we just set the value, don't we? Oh. Hang on, return. What do I mean return? Okay, so that's then just going to come through to seek set, right? This is seek set. What am I doing? Oh dear. I mean, I guess we're just setting the value and returning 1. Again, I can't remember what fseek returns. Return values, return values. Fseek returns 0 if successful, or -1. Okay, fine. So we'll just set the value and return 0 then. Straw. Offset. Relative to current position. We don't need to ask what the current position is because we know it. So let's say return call yourself string not offset plus the new offset relative to end. That should be the same then. Okay. Okay, I think that is everything, and when we close the stream it does clear the flag. Yes it does, okay. Right, so this will probably die, and I suspect it'll die because we'll have made the scratch buffer much smaller since we're no longer opening file whole images with it. Let's find out. Wait, what? I'm in the wrong place. That's not going to help. So, try that again. Oh, this terminal doesn't fit properly on the stream. Cool. I've cut the top off. That's better. Right, what's this error? Scratch buffer was not declared. File 382. Rolling. Scratch buffer. What is it called? Scratch contents. Tisk. Right again. Well, file 394. Send in read-only object. Oh, really? Of course it is. Yeah, I suppose it would have been const before. It no longer is. It's what are these? It's the whole argument with C const, isn't it? It's like logically const, but not bitwise const. Fine. Easiest method, as always, just take the consts out. No, you don't need it, do you? Oh, you will do, because I'm going to need to update read offset. Oh dear, oh dear. Oh, right, this code. Oh, wait a minute. Plus equals actually red. So you can't be const anymore. You can't be const. You're fine. You can't. Well, you can. No, you can't because you're going to pass it through. Stream position is fine. Stream seek is not. That's it. Yeah. I'm now going to forget which ones of those I've just changed. Stream value is fine. Read streams not. Skip streams not. Stream seek. That's the other one. It's just 3, right? 1, 2, 3, 4. 1, 2, 3, 4. I wasn't considering that one. Oh, I've missed one because I'm not paying attention. Where is it? Maybe it was that way. 2, 3, 4. No, there are definitely 5. Oh, because you need to pass it through. Yes, sorry, silly me. That's done. Aye. Trying in. Okie dokie. Which one do I want? Oh, DOSBox X, which is this guy. Don't need to do anything because this is just going off the hard drive. So I should just be able to run. It's already died. Let's not look at the log there. We can look at it here. I'm going to find it. There it is. Yes, that's what I thought. That's 500k. Oh, it's the intro. Oh, yes. Yes, we're not going to want to open everything. Cached. Just a lot of things. It's going to have to be a flag. Yay. Okay. Where can we do that most sensibly? Open stream when we open the stream, I guess. Okay, fine. Oh, finished. Open stream. There it is. Oh, finished. Oh, that's really annoying because it means I've got to put that code back. Ugh. How very peeving. Okay, fine. And then I'm going to need to put a flag in here. Finished. So it's false by default. Close that one. If we want to crash it and Scratch is already open, then die. Open stream. If we want to cache it and it's too big, throw an error. Let's do it this way. And the other string document was finished. That's it, right? Okay. And then, irritatingly, I'm going to have to say that one's still fine. I am going to just compare that in source control. The magic of source control. File. Zip. There it is. So that's in read stream. Yes. Stream finished. Then we all that off. Anyways, do all that off. Okay. Finished. Right. That's not right. I'm looking at the wrong code again. Source control is getting very confused. And so am I. Wow. Yes. Finished. Return this. Otherwise, return that. Okay. That remains the same. That does not. Next, seek. Which version needs to do that? Otherwise, return that. Everything else just calls itself, doesn't it? Ah, yeah, but the calculation's different at the bottom. Oh, in the middle number. Do we not have a function that returns that? Get string position. Current position minus the offset. Yeah. And string position is going to return string. Yeah, so we should just be calling this. We should just be calling this, mate. Done. That should be everything. Okay, so we now have the option to cache if we want to, which means because there's only one thing off the top of my head that I can think of that doesn't require caching, I think we should set caching to be on by default. Right. And indeed, actually, this scoped class is going to open it, so okay. Right. So the intro, which is in fact title, where's it gone? There it is. Title screen, right. This is the guy that's going to be using all the memory at the moment. Because he's going to try and open that, which is going to be a 500k file. So at this point, we want to say, don't cache that, thank you. That it. Feels like it should require more than that, but I suppose there's one way to find out. Do we? Oh, it should be the string member file 443. 443. There it is. Try that one again. Doesn't seem to work. Now, presumably this is going to die slightly later. Okay, well the video loaded, so it's fine with that bit. Will it just immediately die as soon as we skip to the next bit? Yes, it will. What's it upset about now? And is it just the size of the scratch buffer again? Which I assume it is. Ooh, crash. Oh, well, off the back of the scratch size being too small. 87k. Well, I don't mind 87k. At least right now. Okay. Scratch size, currently 40. It's 100. We've got Ks to burn. Temporarily. Okay, the video again. Skip that. Oh, someone else called it. 100k is still not enough. No, it's not. There's a 120k file in there. Okay, just to make me slightly less paranoid that I've broken things, I am going to cheat massively and say, do you know what, mate? You can have a meg. You knock yourself out. Which we absolutely do not want a 1 meg scratch buffer, but we can cope with it for a minute. Video, skip. Alright. I can't hear that. I'm trying to think if I've broken the audio, or if that's related to me streaming. I don't see why it would be though. That should start a different track. Still nothing there. Thinks the music's on. Bit mysterious. It's all working. Still no sound. Oh, something's died. And it's Hung DOSBox. Always a good start. And I don't suppose that... No, DOSBox has just gone crackers. Good, fine. In which case we'll go back here for a minute while I look at this log. Oh, interesting. We've blown a memory limit. But not apparently to do with the scratch size. I wonder what that is. That is mysterious. Oh, but also these are all marked as unknown, which suggests... Yes, this is a release build. That's not going to help. Right, I'm going to need to run another DOSBox and plug that into the stream. Oh, that's the same one. No. Go away. I don't want a dead one. Sure. You gonna show me the window on the stream? No. No windows for me. Excellent. Where's DOSBox gone? There it is. Except now it's a weird shape for some reason. Oh, I know, DOSBox quit unexpectedly. Kindly shut up. That's... Oops, I'm wrong. Oh, where am I? I should be in Bill. Why is there nothing on the screen? Did I select the wrong DOSBox? I did. There were two. I picked the wrong one. Skip. Oh, music now. Ow. Ow. It's very loud in my ear. Oh, apparently it's not that loud on the stream. Well, lucky you. Good lord, that's loud. Can I get into the game? Grief, that's loud. No, it still dies. Okay. But what does it tell us here? Shut up about it quitting. I know it quit. I watched it. I know, mate. I was there. So that's MicMod. MicMod is sort of spontaneously allocating more memory than it has done previously. That's very strange. But again, I mean, I'm not mad keen on doing this all day, but we can work around that for now. We can just make this pool bigger, whichever one it is. It's a state pool. It must be the game one because we're coming out of the briefing mode. All right. We can find the old game code, and clearly that number is, for some reason, too small. Fine. In which case, you can have 2 meg, mate. 2 meg for you, 1 meg for the scratch buffer. Everyone gets a meg. Money to burn. Well, that's 86 bucks. Wrong thing. I don't mind set the box. Sure. Right. Oh, I imagine there's a reason you've made that enormous again, OBS. That one? That doesn't look right. That one? That's the one. Excellent. That's huge for some reason. Of course, it's going to change size when it run the game, who knows? A new build, that's what I mean. Skip. Ow. Oh, we've got music. We should be able to get into the game now as well. Yeah, there we go. Alright. Enough of this. My ears can't take it. Good lord. And that's huge again. Great. Can I just squish this down? Does that work? Apparently it does. Okay. So that's a bit odd. I don't really know, because that's obviously a very specific number that was chosen because it fit. But somehow it's now like 60k too small or something, which is a little bit strange. I'm not immediately clear on why that's happening. But anyway, what's in this log? Nothing that interesting. Oh, there we go. So that's how much memory it actually used versus... Well, it's actually not that much. Wow. It's about... That's barely 600 bytes. wonder what costs 600 bytes. Anyway, okay, so what do I want to do? Back to main. Remind myself what I was doing. So that's, well, let's test to see if that's fixed. That requires 86 box because DOSBox and all of the other DOS boxes don't simulate the hard disk speed. So, what do I need to do? I need to go to 86 box. I need to take out the CD. I need to put the CD back in again. To run this to get a copy of the new exe. This machine is 4 meg though, so it won't run at all currently. So we're going to lie and say, actually it's 5 meg. It probably still won't fit, so let's give it 8. Ow, much beeping. Oh Lord, that's a loud beep. Oh, I'm going to get it again. Okay, glad that's over. So, the last time I ran this, I've copied the file, haven't I? Don't need to update the resources. So the last time I ran this was before I put the caching into the pack file reeling, and it was really slow to load, which it still will be because that intro video is not being cached anymore. But then getting from the intro video into the front end should be faster. Let's find out. Okay, that was surprisingly fast. Actually a bit thrown by that. Okay, I don't mind that. I am slightly confused why that intro video loaded so quickly though. Interesting. I don't know. But the point is that it ran fine there. Oh, do you know what I should have done? I should have actually taken it into the game. That is way too fast. I don't know how it's doing that. Alright, that's fine. New game, off we go. Okay, that's fine. Skippy, skip, skip, skip. From here into the game. 4, 5. Okay. Okay. 2, 3, and out. Okay, that was all perfectly quick enough for my liking. So we can go back here and get rid of that, and we can say, what can we say? What would be handy? Can very large files be left uncached? Because that would sure be nice. Or we have to do something more complicated, which I probably should have done in the first place, which is to just have a cache of a fixed size and just f-read into that cache as we need it, as we need the data. That is much more fiddly, or at least it would be more fiddly if we were like seeking back and forth within the assets, which none of my code does. Micmod does. Micmod is all over the file. So that Micmod's not using this caching though. Micmod, oh, hang on. No, it is. It must be. Okay. That potentially explains the memory increase. Getting into game. Maybe. But to determine whether large files can be left uncached, we actually need to know what the largest files are. So what we can probably do there is we can probably have the pack script tell us. Because I believe if we've got verbose on, there it is. Oh, it does actually already tell us the size. Okay. Well, let's give that a go then. I can't remember how to run it. Is it just pack list? Yes, it is. So, Python 3, PackPy, 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 and then the order is list and pack file. The list is pack list text. The pack file is pack.pack. And I should like a verbose switch. Whee! Right, so it's a 38K. Oh, hello. Well, that's the video, so we can ignore that one because we're not caching that one. It's 500K, but it is loading mysteriously quickly now. Used to take a very long time to load that, and now it no longer does, which perplexes me. Anyway, that's 38K. That's 60K there. That's a sound effect. What else is in this? Oh, hello. Ah, okay. Of course, yes, I should have guessed that. That's the title theme. Is like 120K. So that's the biggest one. So I wonder. Yes, so we could set those to be uncached, but I think it might get very slow. Because I know because I debugged the code. I went through the code when I was adding the custom allocator, but I know micmod is all over the file when it opens a music track. It'll read a little bit from the header, it'll skip to the end of the file and read 8 bits there, it'll skip back to the header again, it'll read a chunk out of the middle, like it's all over the map. And I suspect that is probably the worst possible way of reading a file on DOS. Well, let's try it and find out. So that's going to be whenever we open music. Why does that need saving? Oh, because of that. Okay. Well, let's do it in the front end first. Title screen doesn't have any music yet. Front end. There it is. Okay. Do you load the music here? Yes, you do. Of course, it's inside its own function. So we're going to have to set it for all the music then, which is not necessarily a bad thing. Audio music load. Interesting. Right, of course, because it has its own. Oh, I remember. Yes, because it has to pass all that stuff through. What a faff. But it just does it as an open stream, so if we did it with a cache there and then rewrote all of these. What a pain. Right, well, this is going into source control. That's what's going to happen now, in case this turns out to be a terrible idea. Does any of this not need to go into source control? I don't think so. Caching. That file reads. God, kind of a dramatic crescendo for this moment. Right, home stream. Don't cache it. And oh, do you know what though? If we're just using that interface, we don't need to change any of that. Hurrah for interfaces! Okay. All right. Well, we can give it a go and see what happens. I'm in the wrong folder. I want to be here. Oh, what do? What do? Ouch. And DOS box, at least to start with. And just to check that it runs at all. What have we done? We've made MechMod load raw. It really shouldn't make a difference then, at least in terms of functionality. Like it's not going to crash or anything. Ow. Yep, that works. Ow. Okay, good. But has it affected speed? We shall need to ask 86box for that. Get me a new exe, please. Don't need new assets, we can just run. 2. Okay, that's fine. Is this slower? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is this even allowed? There we go. Just at the point where I thought it was broken. Right, that took 15 seconds to load. That's BS is what that is, or at least it's not shippable, not in my view. 15 seconds to load a music track. Are you kidding me? I guess that means I'm just going to have to cache them. I don't know that we've got any choice there. If MechMod's going to load them in such a silly way, then there's not a lot I can do about that. I mean, I suppose MechMod's not being silly, it's just not doing any of its own caching, really. Okay, back to the code. Where is it? If I get rid of this, I was going to say the scratch buffer needs to be like 125k to be able to fit that title theme in, which I really don't like. Alternatives are a more intelligent caching system for all files, which honestly seems slightly overkill because we only need it for the music tracks. The alternative is we're already using this slightly peculiar interface for MechMod, because MechMod is, as you can see here, this is a load generic, and you give it a structure with these callbacks, and that's how it loads the file, is via these callbacks. So I'm using these callbacks to then interface to the pack file reader back end. But maybe what we should be doing is at this point we should be having, yeah, because we've got a pool, we're past a pool at this point. So use past again pool to store scratch. Well, it's not scratch, to store, to cache file contents. As file contents from memory to load. So basically we cache at that point instead of at the file layer. I do prefer that. Do I? Because, okay, that causes another problem. Because I've deliberately made these sort of memory pools that you're passing in where you're doing all your allocations from, they're deliberately extremely simple in terms of the functionality. So a memory pool is just a big pre-allocated block of memory. and then you can allocate chunks of that pool until it runs out. The problem is it doesn't support freeing chunks of memory, because the idea is you're going to have a mempool for like the game state, and you're not going to free anything while the game's running. You're just going to load a bunch of assets. And then once you've quit the game, or you've won the game, or what, you've left the game state for whatever reason, then we can unload everything at once by just throwing away the whole pool. Right, that was the whole idea with the memory pools. So, unless we did actual OS level dynamic allocation at this point, we're not going to get that memory back. So I think we're just going to have to cache it. I think we're just going to have to take the hit and just say, no, it is cached. Meaning the scratch buffer will have to be 125k. Which is upsetting because that's 85k higher than it needed to be. Can't think of a more sensible way of dealing with it there. I'm actually sitting here thinking entirely mad things about how technically during load I've got an extra 256k that I could use on the VGA card. So I could... No, that would be horrible. It would be a grisly hack, and it probably wouldn't be that fast anyway. It wouldn't be much of a cache to load the mod file into VGA memory and then have micmod parse that. I mean, it'd be fun, but it probably wouldn't help. So, okay, stop thinking about that. Let's just say 125k scratch is fine. I really don't like it. But it's smaller than a meg, at least. So we can do that. We should probably put this down as well. That, in theory, should be that. Let's give that a go. Make sure that all still fits in memory. Excuse me. Spontaneous yawn. Gosh, it's 4:30 already. I shall have to feed Dora the pussycat very soon. Right. Update. What are we testing here? That nothing is slow and that it doesn't blow any of its internal memory limits. Should all be fine. It's not dinner time for half an hour, pussycat. You'll have to wait. Half an hour. You could go. The life of a cat owner. Or a dog owner, let's be honest. Right. Yep. Alright. Carry on, carry on, carry on, carry on. Okay. That's fine. That's fine. Okay. It all fits in memory at least. Let's have a quick check. Good chunk. Is there anything with memory left over? No, there isn't. Everything's free zero. So those limits are all correct now. But what I could do with doing, actually, there's another line in there somewhere. Peak pool memory 1379791, 1.3 meg. And you would think 1.3 meg would easily fit on a 4 meg machine, but it does not, because DOS. Okay, but that number is important, 1379791. I'm just going to put that here confusingly, 1379791, I think. 1379791. Yes, okay, good, fine. So in theory, because this is the thing I actually wanted to test, is right down here. Oh, in fact, it's commented out currently because it doesn't work. But I'd like to know ahead of time whether we're going to run out of memory on it. And this has been a real pain on DOS. Because it turns out the question, how much free memory is there? Nobody seems to want to be able to answer that. The DPMI can't give me a sensible answer. DOS can only lie. And so, yeah, the state that I'm at now is... Because with a 4 meg machine, there's certainly enough memory to run the FMV, there's enough memory to get into the front end, there's enough memory to show the briefing, and then you get into game and it goes bang. I don't have enough memory for that. So given that everything is in fixed memory pools, I should be able to say my game never uses any more than this precise number of bytes. So I should be able to say on startup, do you have this many bytes free right now? And if it says yes, we should be fine. But what I've discovered is if I say that, it'll go, yes, I've got 100 bytes free, and I'll go, great, can I use them? And it'll go, no, there's not enough memory. Lol. So, and this is, you know, it's not totally unreasonable because things like the DPMIs, keeping track of all the allocations, that's got to go somewhere, all of that sort of business. But it does mean knowing ahead of time whether the game will run is not actually a very easy question to answer. Right, so this is going to be an interesting test. We're now deliberately allocating that much memory right up front and then freeing it. Just to test to see if we have enough memory at all. And if this behaves the way it has done previously, if I run that on a 4 meg machine, the 4 meg machine will go, yeah, I've got that much memory, and then it'll die anyway. Alright. Back to DOSBox, to 86 bots. Now, what I'll do then is I will put this back to 4 meg, which means rebooting and much beeping. Ow! So loud, so very loud. It's gonna beep again. There we go. Beeping over. I am gonna need to eject my CD, put it back in again, and copy over the exe. Dear me, Dor is terribly grumpy because I haven't given her dinner early. 20 minutes, Menace. It's not dinner time yet. Is it? No, it's not. Right. What am I even doing before I was put off by a cat? Yes, so this should, if there isn't enough memory to run the game, this should fail immediately and go, I haven't got enough memory. But I suspect it'll go, yeah, I've got that memory, and then it'll fail later. Yeah, there we go. It thinks it's got enough memory. It's gone into the front end. We'll probably make it into the briefing. I think we've got the memory for that. There we go. And then we come out of that and we go into the game and it it... I forget it takes age. Oh, good grief. It fits. What a time to be alive. I was not expecting that to work. Well, now I don't know where I am. How much memory is it using? Have we actually got it to fit now? How much does it say it's got free? 2.8 meg free XMS. It is certainly more than 1.3 meg. Yeah. The problem is, again though, as mentioned, because of this vagueness around how much memory is available, I don't really, for all that 1.3 meg is substantially lower than 2.8, I'm willing to bet a significant amount of money that I cannot fit 1.5 meg more content into this game and still have it fit. I suspect we've probably got something like about 100k free or something like that. Where's my peak pool memory? There it is. It's still the same. Okay. I mean, I would hope it would be. Okay. Well, I mean, I'm going to take that as good. Even if it is a bit puzzling. That doesn't need to be there anymore. And actually, let's just for a sanity check, this unfortunately will make more beeps. Let's say this is only a 2 meg machine. Now, beeping. Sharp with your beeping. You don't want any more beeps, except this one. Beep. Thank you. Right, this definitely will not run. Said that last time, but this definitely won't run. And it should, I would imagine, how much does it say we've got free? We're only got 780k free XMS. Now, 780k is a heck of a lot less than 1.3 meg. So if we run this, it should tell us to get wrecked. None of memory, right? That went fine. 3 meg though, which isn't really an amount of memory you would ever have had. Take this out to avoid the beeps. Let's see what it says about 3 meg. Get on with it. Get on with it. Now, what does this thing say? It says I've got 1.8 meg free. The game only uses 1.3. This should fit. I do wish you could hear the sounds my cat makes. Anyway, right, let's run this. There should be a 500k buffer here. We should be plenty small enough to fit in this space. Oh, there we go. You see, that's what I was looking for. That, we've tried to allocate the memory. We've been given a 1.3 meg block, so it's definitely got that. But as soon as we start actually trying to allocate anything sensible, no, we don't have the memory for it. So, it's difficult to think how to deal with this properly, because let me put the code back on screen. Because evidently this is caused by things that are not directly under my control. Things like if I allocate a bunch of things. So there's a difference between saying, can I have a 1.3 meg block of memory, and saying, can I have 4 256k blocks of memory? Because each allocation itself has to be recorded within the DPMI. And so, and that's going to be, what's the term for that? That's going to be paged itself. So the more allocations you make, the more memory the DPMI is going to allocate for itself to keep track of all those allocations. So, and if that isn't accounted for by calls to ask for free memory, which it certainly is not. Indeed, there's a page on the DJGPP website that it's got a lot of words on it, that page, but what it basically says is there's a particular call that you can call to get free memory, which is the least inaccurate call, but it's still not going to give you an accurate answer. And so, yeah, it's kind of irritating that it is just like, it seems to just put their hands up in the air and go, yeah, we can't really tell you how much free memory there is, soz, which is not very useful. But the plan is, the thought is, if the issue is that while I can allocate one block that big, but I can't allocate multiple blocks totaling that size, if that is the case, honestly, it seems unlikely to me, but if that is the case, then I can work around it by taking this buffer allocated right up at the top and then just using that as one giant memory pool. So so basically I ask the OS for this one block, and then I never talk to the OS again because it only ever lies to me and it only ever causes heartache. So maybe that's the best approach. One big lump, and then I divvy that up myself, which I'm sort of partially already doing with these memory pools. But there are multiple memory pools. And essentially this is talking about just making, well, it's not really one, but yeah, making one overall memory pool. Now, having said all of that, there are so few memory pools in the game. There's one per state, each game state, which is like, you know, the front end, the title screen, the game itself. Each one of those has its own. So there's 1, 2, 3, 4, 5, 6, 7 pools there. Audio gets its own, that's 8. That's it. There are just 8 pools. So there should only ever be 8 calls to malloc or calloc. And 8 allocations, I can't believe 8 allocations is enough to cause the DPMI to go, oh heck, I'm going to need another half meg to write down all of these allocations in. That it's just not enough. So I feel like there's something else going on here, but I don't know what it is yet. Again, because of the limited number of allocations, it can't really be fragmentation. I was concerned about fragmentation in the Jam game, which is why, fragmentation caused by Micmod, because Micmod did its own memory allocations for the Jam version of the game, which is why I've now modified Micmod in this version to use my memory pools instead, deliberately to avoid that problem. But we still have this strange issue where if I ask for the one block, it'll say, yeah, that's fine. But as soon as I ask for multiple blocks totaling that size, it can't find the memory for it. That's peculiar. But either way, I need to go and feed a cat. So I will probably do that. And I may well feed myself while I'm there. Not cat food, I hasten to add. Have you ever smelled cat food? It smells the same going in as it does coming out. It's gruesome stuff. Anyway, well, I'll probably feed myself. And that means I'm going to finish here. I'll probably be on later on at some point. I don't know, maybe about 6, if anyone cares. Right. I will see you all later. Ta-ta.